Working with right angle triangle ABC, we will start by naming the sides relative to angle A. So really what we are doing is looking from angle A. The side opposite angle A, which is BC, is called the opposite side. AC will remain the hypotenuse of the triangle regardless from which angle you are looking from. AB is the adjacent side to angle A. Now notice how the names of the sides will change when we look from angle C. Remember that opposite refers to the side directly across from the angle in question, and adjacent means next to. So looking from angle C, side BC is the adjacent side, AC remains the hypotenuse, and side AB is the opposite side. There are three ratios that are particularly important. The opposite side over the hypotenuse is called sine, and on the calculator it is the sine button. The adjacent side over the hypotenuse is called cosine, or cos for short. The opposite over the adjacent side is called tangent, or tan for short. Guys, you have to be familiar with all of these ratios and know which one we are talking about when we refer to sine, cos, or tan. We will also later on discover how to use the sine, cos, and tan buttons on your calculator. You have to be able to understand when to use each of the trig ratios. This will depend on the information that you are given in the question. But firstly, you need to remember what each of the ratios represents. So sine, remember we said, is opposite over hypotenuse. So we can say sine is O over H. Cos was adjacent over hypotenuse, and tan was opposite over adjacent. So an easy way to remember this is it sort of sounds like so, ka, toa. So that's one way you can remember it. Or another way is some old hens cackle and howl till old age. So that's just a way for you to remember what each of the trig ratios stand for. So if we say sine, we mean we are referring to the ratio of opposite over hypotenuse. Now, a trig ratio is a numerical value. It is not an angle. So when we are speaking of trig ratios, we are talking of an actual numerical value. If we look at triangle PQR, we see that Q is the 90 degree, that's your right angle. So the side opposite Q will be the hypotenuse. And this will remain the hypotenuse regardless of which angle we look from. They would like us to write the following as ratios of the sides in triangle PQR. So firstly, we are asked to find the ratio of sine of angle P. Now guys, a sine or a cos or a tan without an angle is meaningless. So we have to have a reference angle in order for us to write down a ratio. In this case, our reference angle is P. So we are looking from angle P, this is where we're starting from, and we want to know what sine of that angle is. Firstly, if we are at angle P, let's just write down which is our adjacent side and which is our opposite side. So if that's angle P, the side that's directly opposite, we will call the opposite side, and the side that's directly next to angle P, we will call the adjacent side. Remember, adjacent means next to. So for sine of P, we know that sine is opposite over hypotenuse. Therefore, sine of angle P would be the opposite side QR over the hypotenuse, which is side PR. So sine of P will be the ratio QR over PR. Okay, so that's sine. First we said that's opposite over hypotenuse. That tells us which sides we're referring to, and then straight away from there we can write down the letters of the relevant sides. So still looking from angle P, but this time we want the ratio for cos. Remember cos, ca is A over H. adjacent over hypotenuse. So we go back to our diagram. We see the adjacent side to angle P is side PQ. The hypotenuse will remain the hypotenuse. So therefore, cos of angle P is going to be PQ over PR. And then in the last one, we now change the angle and we go to angle R. Here we would like tan of angle R. Remember that tan is opposite over adjacent. So we go to angle R. And from angle R, our adjacent and opposite sides are now going to be different. The side opposite angle R would be the opposite side. And the side adjacent to angle R is side QR. And as you can see, your hypotenuse is still the hypotenuse. We are looking for tan of angle R, so tan will be the ratio opposite over adjacent, so therefore it would be PQ over QR. So tan of angle R is PQ over QR. So guys, what this little example has just shown you is that depending on the angle that you are referring to, your opposite and your adjacent sides can change. Now in this diagram, we are given quite a few right-angled triangles. They ask us to look at the diagram and then complete the ratios for the given statements. So obviously this will depend on which triangle we are in. So we start by looking at sine of angle A. Now what you will notice here is angle A falls into two triangles. We have angle A in triangle ACD, and then we also find angle A in triangle ABC. And triangle ACD and ABC are both 90-degree triangles or right-angled triangles. Because remember, using angles on a straight line, if this part of angle D is 90 degrees, then by angles on the straight line, the adjacent angle would also be 90 degrees. So therefore you can see that in triangle ACD, we can get a trigonometry ratio for sine of angle A. So if I'm just looking at the little triangle, and this is angle A, my hypotenuse would be the side opposite the 90 degrees, so that would be side AC. My adjacent angle would be side AD, and the side opposite angle A, which is side CD, would be the opposite side. So sine of A in triangle ACD would be CD over AC. But now, the reason that we have another equal sign here is because this will give us an equivalent ratio if we look in triangle ABC. So now we move to the bigger triangle, which is triangle ABC, and we are going to see from there what ratio we can get for sine of angle A. These will both be equivalent, and as you will see in a later example, it doesn't matter what the sizes are or the lengths of the sides are, the ratios will be equivalent. So once again, we're looking from angle A. In the big triangle, which is now in green, ABC, our hypotenuse, it's always best to first identify your hypotenuse. The one opposite the 90 degree is going to be side AB. From angle A, the opposite side would be side CB, and the adjacent side would be AC. So now by changing the triangle we are in, you can see that we have changed our opposite, adjacent, and hypotenuse sides. So sine of angle A, looking from angle A in the big triangle, is going to be the opposite side, which is CB or BC, over the hypotenuse of the big triangle, which is AB. And these ratios are equivalent as they both describe sine of the same angle. So these ratios are equivalent. Okay, let's move on to cos of angle B. So now we've changed our angle. We're no longer at angle A. We've now changed to angle B. Alright, and we just need to get rid of all the other markings so that we can just concentrate on the cos part of this. So we're now looking from angle B. Once again, label your adjacent, hypotenuse, and opposite. So my 90 degree, we know that we're basically looking at two different triangles with 90 degrees. Either triangle BDE, so that's the one I'm going to put in yellow. So angle B falls in triangle BDE, or in the bigger triangle, triangle ABC. So from angle B and in the little triangle, which is BDE, my hypotenuse would be the one opposite the 90 degrees, so therefore it would be side BD. My opposite side would be the one opposite angle B, which is side DE, and the adjacent side to angle B is side BE. So therefore, if I would like to find cos of angle B, remember cos is given by adjacent over hypotenuse. I go to angle B and I say, well, the adjacent side is BE and the hypotenuse is BD. So cos of angle B in triangle BDE is going to be BE over the hypotenuse in that triangle, which is BD. The other one we can look at is in the big triangle, which is now in green. So still looking from angle B, we see that our 90 degrees at angle C, so the hypotenuse would be side AB. So that would still stay the same as we did when we looked at sine. In triangle ABC, the hypotenuse is AB. The side opposite angle B is AC. And then the side adjacent to angle B in triangle ABC is CB. So the side adjacent to angle B in the big triangle would be side BC. So now looking in the big green triangle, cos of angle B is going to be my adjacent, which is BC, over the hypotenuse, which is AB. So these ratios are equivalent and they all represent cos of B. But you notice that there's a third one that we can do for cos B. We can do a third ratio for cos B, and this comes from the fact that cos B also falls in triangle CDB. So B was not just in the two triangles DEB and ABC. We also find angle B in triangle BCD. So I'll rub off the other markings so that you can see what I'm talking about. And if we now focus on triangle CDB or BCD, we see that we once again have a right angle triangle that angle B falls into. In this triangle, our 90 degree is at angle D. So the side opposite that will be the hypotenuse. We're still interested in cos of angle B. And in triangle BCD, the side opposite angle B is CD, and the side adjacent to angle B is side BD. So therefore, cos of angle B would be the adjacent side, which is BD, over the hypotenuse, which is BC. And as you can see, there were three equivalent ways to represent cos of angle B depending on which triangle the 90 degree fell into. So guys, it's important here to realize that depending on the triangle that you're in, you can get a different ratio, but it will be equivalent to all the other ratios for cos of angle B in this case. The size of a triangle makes no difference to the trig ratio, and this is illustrated in the diagram below. If I'm working in triangle ABC, then tan of theta would be equal to BC over AC, since remember that tan is equal to opposite over adjacent. So therefore tan of theta would be equal to 1,4 over 4, which is equal to 0,35. But if we now move to triangle ADE, where our opposites and our adjacent sides are going to change now, then tan of theta would be equal to DE over AE. This will have the value of 2,45 over 7, which is once again 0,35. And then finally, if we work in the biggest triangle, triangle AFG, tan of theta in that triangle would be equal to FG over AG, and that's going to be equal to 3,5 over 10, which once again has the ratio 0,35.